uh, clean first or bioremediate first before it can be released to the environment. So one of the method they want me to assist them last time back in 2014 was they want to pump all these gases into the microalgae or microalgae bioreactor or photobioreactor, where in this photobioreactor the algae will eventually absorb the nitrogen oxides, okay, carbon oxide, and also sulfur oxides, okay, part of the sulfur oxides, okay, in order for the microalgae to grow. Because this nitrogen oxide, carbon oxide, and sulfur oxide, but sulfur must be minimal, okay, can be used by the microalgae to produce its biomass. Okay, and I successfully developed the system for them. And now the system and also my nutrient formulation for the algae to grow is being used in Tenaga Nasional Berhad power plant at Sri Manjung, Perak. Okay, anyone from Sri Manjung, you can go to there. Okay, you can see maybe, but now I think they are dismantling their photobioreactor there. They want to build a new and a bigger one. Okay, for them to produce bigger biomass. So the biomass of the algae that has been produced in that particular photobioreactor eventually will be pyrolyzed, okay, will be burnt into bio charcoal, okay, bio coal, okay, and eventually will be reused, okay, as to replace the coal that they have used before. Okay, so this is a kind of cyclical and a sustainable way, okay, to produce coal, and meaning the coal that they produce is from the microalgae, and it can be sustainable. Okay, but today I would like to explore, okay, the topic of this microbial cleaning of gases that can be conducted by the microbes. Okay, not only microalgae is considered as one of the microbes. Okay, so but today we are talking about bacteria. Okay, right. So if you look at this particular picture here, so you can see that this is in the United States. Okay, you can see that on the right side. Okay, so the nitrogen dioxide level, okay, is very, very high at the right part of the United States of America. Okay, then whereby this is the area that is heavily with industries and heavy with the traffic. Okay, because you can see that here, the New York is located there, around here. Okay, while on the left side is more towards Washington. This one is a bit clean area. Okay, so the nitrogen dioxide level is quite high at the right side of the US. Okay, right, and this is indicated by the industry level that is so high at this particular area in the United States. And for us in Malaysia, Selangor is one of the heavy polluted area in Malaysia. Okay, so because if you can see that in Selangor State, we have so many industry available in Shah Alam, for instance. Okay, and these gases needs to be removed by the industry before it can be released to the environment, right? Okay, so if you look here, the one that I mentioned to you just now, okay, we have the CO, okay, CO, carbon oxides, carbon monoxide, okay, they can be derived from the car, or okay, and the car also produce nitrogen oxide and NOx, okay, and the factory, and that is due to the anthropogenic sources. Anthropogenic meaning the human activities, okay, will produce VOC, is a volatile oxygen compound, okay, that can be so many gases that are volatile. It can be sulfur oxides, okay, NOx, sulfur nitrogen oxides, even mercury, okay, hydroxyurea can also be produced by anthropogenic sources. Anthropogenic, as I did mention to you earlier, is a human activity. Okay, and from the natural sources, okay, VOC, okay, volatile organic compound, okay, can be also produced. The NOx can also be produced by the natural sources. Okay, and then the gas pollutants. Okay, after rain, it can go down. Okay, back to the earth. Okay, through dry deposition, because some of the gases are heavy, like carbon oxides. Okay, nitrogen oxide, they are a little bit heavy because the molecular weight of this carbon oxide, and so molecular weight of the carbon, okay, and so nitrogen is slightly heavy, so they will deposit, okay, in a dry form and go back to the earth. And it can also be deposited on earth through wet deposition. So whereby the pollutant, okay, that are trapped in the clouds, okay, will be mixed with water molecules and eventually will form acid. Okay, like for NOx, when they combine with water in the cloud, so it will become nitric acid. Salt will become sulfuric acid. The carbon oxide will become carbonic acid, and these are all will be going back to the earth, okay, after raining, or after they are being mixed, okay, with this what do you call that, all these contaminants, okay, and become acid. And most of these gases, okay, when they mix with water, it will become acid and will be deposited as wet deposits, okay, on the earth, right? So VOC is volatile organic compound. SO2, sulfur oxide, NOx, nitrogen oxide, Hg is hydrogen, which is mercury. Okay, these are all the dangerous form of gases that can be produced by industry and also by the transportation system, okay, involving cars, okay, trucks, okay, aeroplanes, okay, and so on and so forth. Right? So how to control these air pollutants is first the principle that we must have is we must have the bioreactor. Okay, why we need the bioreactor? Because we want to use microorganism to grow the microorganism, and the microorganism can only be grown in the bioreactor. And for microalgae, that's what I did with TNBR last time. So the microalgae is being grown in the photobioreactor system, and then the gas will being passed through the bioreactor, and then it's being bioremediated. Okay, right. For the microalgae system, it's being bioremediated by growing the microalgae in the after the gas has been passed through the bioreactor in the solution form, and then the gases dissolve. Okay, but we control the pH because we put buffer. So although uh, acids like nitric acid, sulfuric acid, and also carbonic acid are being produced, okay, but we control the amount that is being transferred into the solution of the algae to grow. And then we have the buffer, okay, to control the pH. So the buffer retain the pH at certain level, and for the microalgae case, we retain it at pH around 7 in order to make the algae happy to grow, but can use all the gases that has been dissolved in the in the photobioreactor. And then eventually all the gases are being absorbed by the microalgae, and then it form into biomass. Okay, so for microorganism, apart from microalgae, we need to use bioreactor without without the photo word, only bioreactor. Okay, bioreactor is a place where we can grow microorganisms such as bacteria. Okay. Okay, on the right side of this picture, this is the simplest design of bioreactor, where the gas pass through a bed of of porous materialized. Okay, so you can see here, okay, in the circle, red circle here, this is actually the place where the microbes will grow, and this is a place where it has a bed of porous material. And this part, we put microbes in here, we immobilize microbes on this particular surface, and after that, we pump in the foul air. Foul air is the air that we don't want. We want to treat basically the dangerous air, okay, the dangerous gases. We pump here, and then after that, this is water makeup in order to make the this biofilter. Okay, we call this region as biofilter to ensure it is wet. Okay, in order to maximize or optimize the absorption of the gases, and also to allow the microbes to grow happily. Okay, and then this water pump, it has a push out. Okay, after this water is being is dirty, then it needs to be pushed out and put with clean water. And then we have a recycle pump here as well in order to recycle the process. So the when this area is wet with water, okay, so the dirty gas, okay, or the dangerous gas will start to dissolve in the water system, where in this particular bed of porous material that is being put at this region containing microbes that are growing, okay, and this area, because we also will put some nutrient, okay, for the algae, for the microbes to grow. So this foul air okay, or the dirty air, we call